that, hey, maybe you should see the patient now, or perhaps the patient should go to the ER now, and be able to prevent something horrible from happening to the patient. Already FDA approved, already in use, and it actually sends reports to the doctor, so it can automatically be uploaded into their EMR. Next slide. Panomic. Next. The reason we have panomics, and panomics is my term for integrated omics, it's all the omics. It's the fact that we've gone to a point in data analytics. Now, I mean, machine learning has been around for decades, right? You can go back to Ada Lovelace in the 1800s, and she wrote the first algorithms for these types of things. So we've had this concept of machine learning and AI for a long time, but we haven't gotten to the point where we had so much data that was digitized. And we hadn't gotten to the point where we had the CPU and the GPUs to run it. But now we have ways to evaluate patients that we never had before. Old model, you had respiratory rate, heart rate, and just when the patient came in to see the doctor. Now we have all these new types of omics, transcriptomics, proteomics, microbiomics, metabolomics, genomics, radiomics, and the list goes on and on. Next slide. And it goes beyond just your typical healthcare data, just what makes up our own bodies. Now we can actually figure out and see what's going on in your environment. And it's not just pharmaceutical companies and your traditional healthcare companies getting into this game. Does anybody remember when Amazon bought Whole Foods? Show of hands. No? Okay, 3 people. It's fine. We'll get back to this. Everybody know what Amazon is?
Yeah.
All right. God, good. All right. Oh, no, go back. Oh, did I do that? All right. So when Amazon bought Whole Foods, obviously it makes sense from a business model to a certain perspective. They sell things, so now they're going to sell groceries. When they bought Whole Foods, that was always a healthcare play. It was never about selling groceries. And I'll come back to that in a second. IBM, same concept. I worked for IBM for 6 years. I was Associate Chief Health Officer. I was over all of their AI applications, from clinical trials matching to oncology, the list goes on and on. They bought the weather company. Yes, all right, they can do data analytics on it. That's a healthcare play. Next slide. After they bought the weather company, 3 to 6 months later, you get this. Watson for allergy tracking. So think about these applications when you can start developing these things that show you what's going on around you. Imagine you start integrating these types of applications with Alexa. Let's say you have a business meeting in Bangkok, and you just traveled there, you just landed, and you set up your business meetings in the afternoon because you want to go for a run in the morning. However, your digital AI assistant that's tied into your calendar realizes that there's going to be either high pollution or high pollen rate in the morning during your run. So based on your genomics or your panomics, now your digital AI assistant realizes you have a 96% chance of having an exacerbation of your asthma. So it changes your calendar around to have your meetings in the morning and then have your run in the afternoon when you have a less than 3% chance of getting affected by pollen rate. Next slide. So again, all these different types of ways that we can analyze new types of data. That's me at NASA iTech evaluating this next application. Next slide. So this is Context AI. Context AI has developed a unique biomarker. So this is a startup that's got spun out from iTech. They can evaluate the electrical activity, not just in the heart, but throughout all the cells in your body at the same time. It also has haptic response, and it can evaluate the pressure in real time, and they're using smart textiles to do this, so they can evaluate all this new data. The thing is, they're applying AI applications to it because you have all these new biometrics that we've never known what that means. All right, so what does it mean that I have certain cardiac rhythms or certain electrical activity in the cells in my hand? We don't know, so we have to learn that. But they have partnerships now with UCSF and Stanford, and they've been able to predict cardiovascular diseases in utero, so from fetuses. So they have ones that they apply to adults, but they also have ones that they apply to the fetus. Next slide. Do I have to? Oh. Other smart textiles. This, again, these are things that are already out there. So things you can apply to your shoes, to your clothes, things that can receive information, new biomarkers. But then from a physician's perspective, these are ways that we can actually send information back to the patient. And imagine from just a regular use perspective, things that if you're cold can adjust the heat in your shoe, or if you're hot can give you better air conditioning in your body, or it can turn into a flashlight. Next. Next. Obviously, augmented reality, mixed reality, virtual reality, new ways that we can interact and see the patients. Next slide. Public. Next. So we're already seeing these AI applications affect us from a public health perspective, being able to identify diseases and outbreaks before even large nation states or local regional folks identify it. Google being able to predict flu or influenza before the CDC could. Next slide. Going back to that Amazon purchase of Whole Foods that we talked about, right after that, about 6 to 12 months after that, they announced this. This is Haven. This is their new healthcare venture. Next slide. Anybody heard of 1492 beside Columbus? 1492 is Amazon Skunkworks. So Alexa, anything that they're doing in healthcare, this 1492 is where they do all that research. Amazon is actually moving to Virginia as well, so they're moving a lot of this research based there. Or potentially. In 1492 has developed a lot of their AI applications. Next. This is an Amazon Go store. So what Amazon has created is, if you've ever been to one, you just take your phone, you scan in, it ties into your Prime account, and then they have RF sensors all over the room as well as cameras for computer vision. And you go and you can just pick anything you want up, and then you walk out with it. It will track what you picked up, it will track what you put back, and it will charge you automatically. It's easy and fast and simple. Why isn't healthcare like this? Now, one interesting thing that they can do, because they have all that computer vision from a healthcare perspective, they've already been evaluating electronic medical records. They now, 1492 has developed an AI application that when you walk into the store with computer vision, they can determine your mood, whether you're depressed, whether you're sad, whether you're happy. They obviously can determine your BMI based on your height and your weight. And so those things, maybe not so novel. Here's where it gets kind of scary and kind of cool at the same time. When you walk into the store, they can predetermine what you're going to buy in the order you're going to buy it, based on previous purchasing models, based on your mood, based on your BMI, and based on potentially any electronic medical record they might have. So, always been a healthcare play, and they're getting bigger into healthcare. Next slide. Blockchain. Everybody who's heard of blockchain? A lot of people heard of blockchain. Cryptocurrency, anybody? Bitcoin? Anyways. Don't buy, this is not a financial disclaimer or anything like that, but the underlying applications of blockchain, everybody knows has great potential, and healthcare is already being applied. There's a lot of blockchain EMRs out there, and the potential for it's phenomenal. Obviously, having a distributed ledger for cybersecurity, very important for the Internet of Things, for hackers to be able to protect from those kinds of applications. And then from the interoperability, being able, from a patient's perspective, if I travel to Poland, being able to take my EMR from Virginia over to Poland seamlessly and back and forth. These are the types of things that people are already working on today, as well as even be able to possibly commoditize your data, seeing as all these companies, whether they're small biotech, large pharmaceuticals, or large IT companies, are getting into this data play now. This is a way that patients could potentially commoditize their data and say, all right, I'll share it with you if you give me 2 cents or whatever. Next slide. And the machine learning or AI applications go beyond just the diagnostics and the point of care. They go into the entire value chain. This was a paper that I wrote with several colleagues based on a book chapter that I wrote of using AI applications beyond just diagnostic imaging. I'm a clinical radiologist by training, still practice some, but I do primarily AI and innovation now. So you can use it anything in the value chain. Imagine the AI application reducing radiation, or the AI application determining how many physicians should be working or how many nurses or technologists need to be working based on the parameters of the population, or based on the time of day, or based on the pollen count, or based on some other disaster. These are the kind of things that it can direct us into the future. Next slide. Other types of technology that are out there already in use, these are autonomous drones. So autonomous drones for emergency situations, if there's an accident, being able to bring in first responders or being able to pull bodies out. This is already being applied for transplants, moving organs around. So this is already going on in the US today. Next slide. Again. Imagine when AI starts applying infrastructure applications, the future of smart cities, being able to determine, all right, where do you need clinics? Where do you need physicians? Based on where the population is going, being able to predict it. And this is already, AI already does this with us today. If you ever use Google Maps or Waze or Apple Maps, when you put in a destination, that's not necessarily the best route for you. It's a good route for you, but it's not necessarily the best route for you. Why? Because it's not just making it a route just for the individual that's using it. It's making routes for the millions of people that are using it at the same time. Next slide. Personalized. The unique thing about medicine of the future, both here and in space, is the fact that we can go and dive in deeper than anything else we've ever done before. We can analyze your genome and create pharmaceuticals for you. It's no longer one size fits all. Right now, if we get sick, if I get sick or anyone else here with cancer or with pneumonia, we all get treated the same way. In the future, and companies are already doing this, it's no longer one size fits all, but it's individual for me, being able to look at my genomics and creating drugs specifically for me and for my disease. Next slide. A lot of companies are already doing this. We do this a lot to help develop the AI applications for these companies, so be able to develop the platforms to ingest, curate, and segment that data, and then tie it with any genomic data they have, or with any clinical drug trials that they're doing, so that they can make personalized applications based on AI. Next slide. Combinostics, this is a company that's bringing in a bunch of new information, and this is one of the reasons AI is not going to supplant the physicians but augment them, because we have all this new information that we never had before that we're still trying to figure out what we do with it. But this is the level of personalization that we can get to right now. Next slide. This is another spin out that came out from the iTech program. This